Welcome to our fourth webinar on lockout tagout. The webinar will deal with today with a particularly difficult topic in the field of occupational health and safety, and that's control of hazardous energy and lockout tagout. Just as a preamble, this is an area where I spent a good part of my previous career in terms of training, developing procedures, and unfortunately in court defending companies on very serious accidents related to failure to properly engage in lockout tagout. So my knowledge comes from some very difficult situations, and it's on that basis that I want to illustrate two things. First of all, we're going to talk about, if you look at the agenda, we're going to go over the safety group. We're going to talk a little bit about your legal responsibilities as employers, talk about a safe work procedure. But most importantly, we're going to talk about the health risks associated with contacting hazardous energy, the types of energy sources in the workplace typical in the pallet industry, and some common hazards and prevention techniques. The key issue that I want to address right at the very start is the disclaimer. Now, this lockout tagout, it has generally two aspects to it. First is there's a generic training that you would teach all employees, and then there's workplace-specific procedures on each of the pieces of equipment that you have inside the facility. And it's very important that we understand at the outset that this training document is in no way, shape, or form designed to be all-encompassing for your lockout tagout training. What's missing is the workplace-specific procedures for the machines inside your facility. So, for example, something that's simple would be locking out a forklift if it was defective, and locking out a forklift might be as simple as putting a cover over it or a chain to lock the machine out. But if you're, for example, working on a stacker, that's a very difficult and complicated process to de-energize, and you need professional help either from the manufacturer of the stacker or from a health and safety consultant in order to properly design your procedures and your training program. So this is a generic or a general training, general orientation to lockout tagout. And once again, it's not meant to be all-encompassing. There's significant extra work required for you to be able to have a robust lockout tagout program in your facility. So, once again, who delivers the training in your facility? It's defined as a competent person, and when it comes to lockout tagout, this is particularly difficult because who's competent to deliver the training? And that training has two functions. One is how to actually do the job, but secondly, how do you communicate something that's fairly technical in nature to individuals who might not quite understand issues that are that technical. For example, if you're trying to explain how to dump air off a pneumatic line, that might be in itself very difficult, especially if you have different languages in the workplace or different understandings of how machinery works. In the past, what I've done is used somebody who has trained the trainer competencies and a mechanic or a millwright that's working inside the facility that understands the nature of how those machines operate. The regulations for many of the people who attend these webinars are in Ontario, and I've cited the regs there in front of you. I think the key point to understand is that the regulations are changing over time, and the reason for that is the Canadian Standards Association has brought out one of their standards called Z46005, Controlled Hazardous Energy Lockout and Other Methods. And slowly, the various provincial jurisdictions are using that as a reference point for their new legislation. So that's the other standard that you should be aware of when designing your own plant-specific lockout-tagout procedures. Once again, it's important that only competent people should be writing your lockout-tagout procedures and delivering the training. And for that reason, I emphasize once again that when you're doing the training, what I've done in the past, and my recommendation, is that you have the mechanic that's familiar with that piece of equipment there helping to facilitate the training. A supervisor that's giving the training may not clearly understand either the type of energy or the magnitude. And magnitude is simply described as a big difference between handling 120 volt or 570 volt. There's a big difference between primary sources of energy and secondary sources of energy, which a supervisor may not have any awareness of, but the mechanic does. So this is a very important part to deal with when you're delivering training. You have to look into your workforce and see who's competent in delivering this type of training and who has the knowledge. And if you need 2 people, then 2 people it should be. So these are the regs across the provinces. You know, they were current as to about a year ago. They may have changed a little bit, but it gives you an idea of where to look for the regulations. And if you're surprised at the detail and the amount of information, it's because most provincial jurisdictions treat this as a very, very, very serious issue. And as a result of some, you know, the critical injuries that result from people not following these proper procedures, and it's evolving. So, for example, around electrical lockout-tagout, there's new legislation coming down the pipe on how you approach those your main panels, and there's a requirement that's evolving saying that you have to use arc flash protection equipment. It's brand new. A lot of people aren't aware of it, but I think it's certainly in the Ontario regs. The key point that we want to understand is this is evolving legislation, and you want to be current with some of the changes that are going on. So in terms of training, once again, what the association is trying to do is provide its members with some safety standards, or in some cases, safe work practices, which are written methods of how to perform a task. In talking to many of our members, what we found was that they didn't have good quality or high quality training presentations that they could review with their staff. So we've customized these training presentations like you see in front of you. These presentations are a combination of narrative and photos of the equipment and the lockout devices in use. So when you're building your own workplace-specific documents, I'd encourage you to take the time to go through the plant, take pictures of the devices and the machines that you're trying to develop procedures for, and use visual aids to instruct your staff on how to do a proper lockout-tagout. My experience, visual aids are paramount in terms of communicating this information to staff. And once these procedures are built, my recommendation and my past practice is that they're not only maintained in a manual, but they're posted to each piece of equipment inside the facility. So that's in a laminated folder, and it's posted on a gate or on the actual machine as a reference point for when the work is being done. and that'll become clear when we look at the 8 steps involved in locking out a piece of equipment. It also incorporates a training assessment, so the one that we've put in place here is a small one, but in the case of lockout tagout, I would never rely solely on a written assessment. I would insist that the employee be asked to demonstrate his competency in the field on the machine that we're talking about. And the training record, so what we provide is a record of the date, the time, the individual, who the trainer was, and the course content. And that's a best practice for any time that the local regulatory authorities visit your site. If you want to impress them and demonstrate due diligence, then I would strongly encourage you to use that format that we post on our website, and at the back of it include the training document that we're going through right now, customized to your facility, of course. Okay, so what are we going to be able to learn once we finish this? Well, we're going to be able to understand the principles of lockout tagout, become familiar with where to find the provincial legislation on lockout tagout, understand the difference between an affected and unauthorized worker when performing lockout tagout, understand the safety standard that we've developed in order to instruct people on how to do this work properly, understand employer responsibilities when using contractors. And the point that should be mentioned here is in many situations, employers don't have highly skilled or licensed maintenance personnel doing their major mechanical, electrical, hydraulic, or pneumatic maintenance. They hire an outside contractor. So in that case, that presents some particular difficulties in A, you don't have on site that local talent or resource in order to fully describe your procedures. But more importantly, how do you tell that contractor that you want him to follow your procedures, not any that he's developed himself, when he's doing work on your site? In my experience, that's been a big challenge, trying to get contractors to follow your plant-specific procedures. We also are going to look at identifying different types of energy sources in the workplace and what is required of machine-specific controls. And then we'll look at the 8 steps for lockout tagout and the 4 steps for returning or restoring equipment to service. So part of the orientation training is to make people familiar with LOTO definitions. So going down the list is to talk about hazardous forms of hazardous energy, and that's any electrical, mechanical, hydraulic, pneumatic, chemical, thermal, radiation, kinetic, or any other type of energy that can harm people. And by kinetic, what I mean is gravity, and this is often forgotten when looking at energy sources, but in the pallet industry, gravity probably represents one of the highest and most dangerous sources of energy, and that comes from falling pallets, typically on a machine, a stacker, or a conveyor system, where the potential is for the pallets to fall onto an individual while you're engaged in a lockout procedure. And typically those are some of the most difficult types of energy sources to control properly. Energized is a term used to mean that when something is connected to an energy source or containing residual or stored energy. And what's important to understand is that in lockout tagout, one of the fundamental concepts is that in order to do lockout tagout properly, you have to render a piece of equipment to a zero energy state, and you do that by either severing its source to the main energy supply, or you dissipate it. And dissipating means bleeding the air, bleeding the hydraulic system, so that there's no residual energy or stored energy. This is a difficult concept to get across to people, but it's fundamental to the lockout-tagout procedure. De-energized, as it says, it's disconnected from all energy sources, and it means that there's no residual or stored energy to be dealt with. An energy isolation device is a mechanical device that physically prevents the transmission or release of energy. And an example is demonstrated in the photo. What's important to understand about these ISO devices is that on some of the newer equipment, certainly if it's manufactured in Canada, they would be required to meet this standard. If the equipment is coming from Europe, it would have what we call a CE marking, and it would also be something that you would find on virtually any piece of equipment brought in from Italy, France, England, Germany. However, from the United States, the rules on where and how ISO devices are installed are not to a Canadian standard. So that while they may well have them, they might not have them in every location that a Canadian manufacturer would be required to put them. A good best practice is to have either U.S. equipment manufacturers read and understand the Canadian standard that we talked about earlier, is at 460, or if they're not prepared to meet that standard, when the equipment is brought into Canada, have a safety consultant go over it and have a look and see if the ISO devices meet both a frequency and a location specification set in Canada. If you need some help in finding somebody that can do that, contact me at the Ottawa office, and I'll put you in place with such an individual. A HASP is it's a device that is capable of accepting several locks, and what a HASP does is it allows multiple authorized individuals, and by that I mean if you have 3 mechanics and a contractor doing work on a machine, then your 3 mechanics and the contractor would each put their lock on the HASP at the ISO point in order to ensure that none of that maintenance team is working when they shouldn't be working. The next LOTO definition is lockout, which, as you can read there, is a placement of a lockout device. And a lockout device, you see, typically it's contained in a red box or yellow box, and you see some of them pictured in front of you. These can be hasps. These are locks. There's different types of controls that you can put on the ends of plugs. You can put covers over levers and taps, but it's designed to ensure that the device, the energy isolation device, cannot be turned back on until the lockout device is removed. A lockout device is any mechanical means of locking that uses an individual keyed lock. And the key thing to remember there is this: you'd never use a lock with multiple locks with one key. This is an individual lock, one key, and it's secured to an isolation device in a position that prevents the energy from being restored to the machine. And we'll give you some examples of that later on. But the challenges in trying to get understanding around this is around where exactly is the key maintained. Some plants maintain a board with the locks in it. Others allow maintenance personnel to have their own lock. I've seen both used with in practical situations. Either or is good as long as you have a policy on how that lock is applied, when it's removed, and that there's good control on the locks. an information tag. So we saw what those tags looked like. The tags are used for two means. One is a warning, explaining to people that the piece of equipment has been locked out, but also it explains the type of repair work being done, why it's being locked out, when the lock was applied. And this is important for a couple of reasons. One, in some situations where equipment is shut down between shifts, if the mechanic leaves and who applied the lock initially leaves the site, the next mechanic that comes in is faced with the problem of finding out who applied the lock and what can be done to restore that piece of equipment back to service. So that information on it, who applied it, why it was applied, is critical to a proper and functioning lockout-tagout system. We'll talk a little bit more about how to handle lockout-tagout, which crosses over 2 shifts or over an evening, but that's what the information tag is designed to be used for. The next two definitions are unfamiliar to many people in my experience, but it's a term that terms that you should be familiar with. One is an authorized employee. That's an employee who performs the servicing or maintenance of machines and is trained to a much higher standard on lockout-tagout. And these are typically maintenance personnel and or supervisors. So supervisors can be considered authorized personnel as long as they get the proper training for this. And all legislation, all training, all documentation should typically refer to who are authorized personnel to do lockout-tagout, and a list should be posted. More importantly, affected employees, that means the employees who are performing duties around that piece of equipment and are affected by the lockout-tagout, should be clearly instructed not to engage in any lockout-tagout duties that they're not trained for. And making that distinction is a very important one. In my experience, most affected employees who are severely injured in the workplace were trying to either clear jams or get machines back into operation, which they clearly were not supposed to be doing. And perhaps they'd done it a couple of times and no one had, they hadn't gotten hurt. But in this time, this particular case, the conditions had changed and they got severely injured. And when asked afterwards why were they doing this duty, we find out that they weren't trained properly and they were engaged in a level of activity they clearly should not have been. So trying to explain to your workforce that there is a certain number of people that can do lockout-tagout and the rest of the employees should not be engaged in this type of activity is a very key responsibility of employers in the workplace. So energy control procedures. So these are 8 procedures that I've engaged in over my career, and some people cut it down to 6. But this is how most professionals would delineate a preparation for shutting down a piece of equipment. And just to go over them, first of all, you would notify all affected workers, and that means let's picture that you're shutting down a stacker on a new pallet line, and it's malfunctioning or it's jammed, and you've got to shut it down and clear the jam or fix the malfunction. So first of all, you would notify all the affected workers. That would be your forklift operators, anybody on the nailing line, that the piece of equipment is being shut down, and it requires lockout-tagout procedures. That means they've got to stand away from it. The line's being shut down. How you do this? There's several ways. You can pull them together as a group. You can have an alarm system. But the key thing is to notify all workers that the process is starting. Second step is the authorized worker. That's your maintenance personnel, or in some cases a supervisor, will pull the procedure. So this is critical. Many maintenance people say, well, I know the procedure. It's in my head. Okay, I've done it many times. I know how to do this. My advice is pull the procedure if it's not posted on the machine itself, and have all your procedures in a manual. My best practice was I made sure the manual was next to the maintenance room and that a copy was kept in the welding cart. But make sure that copies are available and make sure they pull that document and read it before they do any work. That procedure will list the type of energy that you're dealing with, how to control it, what the particular hazards are in that piece of machinery, whether there's any redundant systems. It's both descriptive and prescriptive on how to do the lockout procedure. Third step, if the equipment is operating, shut it down in your normal process. And what that means, if you have a control device or a panel or push button, push stop, shut it down that way. One thing I'd encourage everybody to understand is that turning power off with a pull cord or an ISO device is not the proper way to shut down a piece of equipment. It's only to be used in emergency situations. So I would follow, my fourth point is specific, or the third point is specific. Shut it down in your normal procedure that you would do at the end of the shift, end of the day. The fourth is deactivate the energy isolation devices so that the equipment is isolated from any energy source. Now, in many cases, this is difficult to do if you don't have a written procedure where your joint health and safety team and your mechanics have gone through the machine and identified where all of the energy sources are. And on a stacker, you could have both electrical, mechanical, could have hydraulic if it's run that way, or pneumatic. It certainly would have gravitational kinetic energy. So you'd have to isolate all of those devices, and typically you would have an ISO device on the electrical. You may have an ISO device on the hydraulic and the pneumatic, but you certainly wouldn't have any device for kinetic or the other forms of energy. So a key thing to remember here is that not every piece of equipment has a device that you can use to isolate it from the energy source. Number 5 is you would apply your lockout tagout device to the ISO device. So if you remember a few pictures earlier, you saw an ISO device which was for electrical control. So you would turn that device. That device has been installed so it would cut the power feed to the stacker, and you would put your lock on that ISO device. And we'll show you a couple of pictures in a few minutes of the different types of devices used to isolate energy. The sixth step is the dissipation or restraint of stored energy or residual energy. In my experience, this is often skipped or not done properly because it's often time-consuming. So if your device has, for example, on a pneumatic system, a method of dumping the air, purging the air, then people might follow it. But if the device hasn't been installed, and these devices can typically cost $400 or $500, so it's a cost issue when you're building the equipment, and the manufacturer just might not have decided to install that particular piece of equipment. Now you've got a unique challenge where you've got 120 psi on a line operating, for example, a stacker arm, and how do you bleed that? Once again, you've, as an employer, got to do the work to make sure that the process for bleeding the air, bleeding the hydraulic oil, is properly defined, properly understood, and followed. And once again, this is an area where people cut corners on a regular basis, because once you bleed the system fully, of course it delays or makes the startup time a little bit longer. But if you want to make sure of an accident, try to do lockout tagout without properly dissipating residual stored energy. It's a recipe for disaster. So that sixth step, make sure that everybody follows it and follows it properly. Any incident where a mechanic doesn't follow the sixth step and tries to cut corners, grounds for discipline. It's a very, very serious step in the lockout tagout procedure. Seventh, verify the equipment is fully disconnected from all energy sources. And the way you do that is, first you check there's no workers around. By that I mean if you're going to try and start up the machine to make sure she's fully disconnected, what you don't want is a stack of pallets falling over and somebody standing nearby. The way you verify is that you go to your normal control panel and try and turn the stacker on and see if it operates. If it doesn't operate, then you know that the machine is fully locked out. And once it's fully locked out, at step 8, you can begin your work. So that's the process for shutting equipment down. And once again, we'll talk about some energy-specific issues in a few minutes. In my particular experience, the next step is totally forgotten, both in training and practical work. This is where I've seen just some horrendous accidents. And this is around restoring equipment to service. So it's just as important to train your workers, your authorized workers, on how to restore a piece of equipment to service as it is to shut it down. So in this case, you've cleared the jam on the stacker, or you've, let's say you have a crack in a hydraulic lift table and you've replaced that lift table or welded it, you've reinstalled it. How do you return that to service? So I follow a 4-step, or I recommend following a 4-step process, which is to check the equipment and the immediate area around the equipment to ensure that all non-essential items have been removed. That means any tools that have been left in around the equipment, inside the equipment, any pieces of material, bar iron, anything like that is fully removed from the area. Secondly, check the work area to make sure that all the workers have been safely positioned away from the equipment and there's no risk whatsoever of them being struck by a piece of equipment or something coming from the equipment. Number 3, remove the lockout devices, re-energize the equipment. Number 4, notify all the affected workers that the servicing or maintenance is completed and the equipment is ready for use. So that communication process is absolutely fundamental to making sure that the workers feel that they're working on a safe piece of equipment and they have trust in the employer's responsibility for maintaining that the equipment is safe to work on. I'd emphasize that in my experience, not following proper procedure on re-energizing equipment has resulted in just some absolutely horrendous accidents on live roller conveyor, on stackers, on transfer lines, on waste grinding equipment, on waste transfer equipment, where we have locks removed and people either doing last-minute repairs or monitoring or doing something on the line and they're not aware that the equipment's being re-energized. That's where accidents happen, and they're always severe. So following a proper procedure for restoring equipment to service is absolutely fundamental to your lockout tagout program. So your different forms of energy in your facility require a different response. Okay, so electrical, for example, is probably the primary source of energy that you're dealing with at any one time inside the plant. And so let's go over how that's done. So first of all, you'd shut your machine down from normal operations, right? You'd close the main disconnect panel. Okay, so that's a very typical or standard control. So there's either a disconnect at the machine, or you go back to your main panel where you know that the power feed to that machine is. And you can see in the picture, in this case, it's a knife switch. So he's got a tag on it, and he locks it out. In my experience, very few people use flash protection, but when you're dealing with the higher voltage levels, 575, which is what operates much of the equipment on a pallet plant, my recommendation is to use flash equipment. I personally have seen what's happened when people haven't used flash equipment, and it can be quite serious. But if you're not using flash equipment, which is the mask, the gloves, the shirt, then a good best practice is to stand clear of the box with your face turned away in case there should be an arc flash. And that's when you activate the knife switch to kill the power. Use an improved padlock, lock the main disconnect switch off, pull the key, retain it. Apply your tag, explain what you're doing. If there's multiple people working on a piece of equipment, you must engage a multiple locks and a group tag. Then you test the main disconnect and verify that it cannot be moved into an on position. So in this case, you would be testing to make sure there's no way that that knife switch can be re-engaged into an on position. Then you try and start the machine using the normal operational controls. And if it doesn't operate, then the assumption is that the power has been disconnected. However, let me emphasize that on many pieces of equipment that I've worked on personally and designed procedures for, there's residual power sources feeding equipment. That's a secondary feed. That might happen for a number of reasons. It might be old, it might be a way it was designed in the past. You'd know that it would be properly inspected in Ontario if it had a CSA sticker on it. But much of the equipment that I see in the field doesn't have a CSA sticker on it. And that, certainly outside the province of Ontario, there is some concern that the electrical hookup may include other energy sources that could still be live. And you want to make sure that your mechanic tests for all energy source, electrical energy sources before he does lockout on a particular piece of equipment. And anybody that's familiar with electricity would be able to test for that, and it would be a voltmeter that he would test with it. So the next step is to make sure that once the electrical is de-energized, that you look at the other energy sources, and the way you'd know that there's other energy sources on that particular piece of equipment is to refer back to your written lockout procedure on that equipment, and that would identify whether there's any energy sources such as hydraulics, pneumatics, gravity, and the others that I've mentioned previously. At that point, once all the energy sources are reduced to a zero state, the work is completed. Prior to removing the lockout device, make sure that the normal startup controls are in an off position. Remember, you've tested it once. tested to see if it would start up. You press the button to turn it on. Make sure that it's off before you remove your tags. Then you remove whatever devices that you've had, blocking devices, tools, machines, materials from the machine, inform your staff, move the lockout, reconnect the power, and then start your machine back up. Under hydraulic energy, okay, this hydraulic by meaning oil pressure, this is probably your second most serious or most critical type of energy, and that's typically used on heavy lifting inside a plant, so it's typically inside a stacker, could be in a grinder. But once again, what's important is that you have a good understanding of how the hydraulic energy can be bled off from a pump, and it should have a dump valve. Certainly any new piece of equipment installed in Canada would have a dump valve, but it's quite reasonable that the method for dumping or bleeding off hydraulic pressure on an older piece of equipment is not properly identified, and it's something that would require machine-specific knowledge of. So you'd once again want to understand how to do that, and your mechanic is your best source of that information. And then once it's dumped, there should be a device where you can install a lockout device over the valve to prevent oil to be reapplied into the system. Once again, let me emphasize that older equipment might not have either a control device or a dump valve. There still would be methods of locking it out, but this would require your mechanic to study it, or you'd bring in a health and safety professional who would give you some advice on this. Next type of energy is pneumatic. Once again, it's the same type of situation. Many of us are running with airlines that were installed many years ago, and they might not be familiar with an air dump valve pictured in this slide. I know I installed equipment myself, and only later came to realize that I had no method of bleeding off the airline at 120 psi. On most of the lines, that's enough to really hurt somebody if it's activating a table or a stacker or something like that. So I had to go back and install these air dump valves, and they work well. Only, once again, authorized people should be doing the work, but it's designed to bleed off the air and then lock it out. So the other potential energy sources in a lockout-tagout situation, what we've featured here is where we have a stacker. So this is a device where the pallet is fed to it, and it lifts up, pushes the pallet up, and teeth come under and hold it into position. So in this case, if you had to isolate the energy on that particular piece of equipment, the concern you would have is that pallet coming down on top of you or the operator, and the question would be, how do you get the pallet out of there? And if you can't get the pallet out of there, then you'd have to block the pallet from being able to fall on the operator while he's working on that stacker. The way you would block it is you might use a 4x6 or a 4x4 or a steel bar that would run along the drive chain and support the pallet in its current position. So that's what blocking is all about, and that prevents the pallet from coming down on the worker while he's working. Other types of energy blocks are to pay attention to around springs. There's residual energy in grinding units. Okay, so if you have a rotary grinder and it it jams because maybe it's processing gets caught. Somebody's thrown a hammer or a pry bar, piece of steel in, and it's jammed. You want to remember there's residual energy on that as well, and that has to be bled off. Very complicated process, and you'd have to have a written procedure for that. Something that's quite common in our businesses are pallets that jam along a conveyor line. And once again, you clear the jam, and there's the residual energy of the drive chain or the roller conveyor behind that pallet. Cause quite a bit of damage. So these are all areas where there's potential energy, and it needs to be either bled off or blocked to prevent that energy from being released. Thermal energy, something that's often forgot about when we're doing lockout tagout. In this picture, this is a waste conveyor, and here I have a gearbox, and that those gearboxes can be quite warm, quite hot. I've seen some people get some nasty burns from working on it and not remembering that before you're working on those this type of equipment, you have to make sure that it's allowed to either bled off and get the temperature down, or let it cool down before beginning work on it. So that's thermal energy. And certainly in other businesses, thermal energy can be quite a serious hazard. But we've tried to demonstrate an example for our industry. And then kinetic, once again, we're talking about gravity here and pallets falling down on individuals. And so once again, we've talked about trying to ensure that before any work is done, that you, in this particular case, you'd remove the one pallet, try and get it out of that position, and then block to make sure that the 6 or 7 pallets in the stacker would not be able to come down on the individual working inside the stacker. In some cases, they have to be removed. In other cases, they can be blocked. The key thing to remember is that you need a written description on how you remove that potential energy before engaged in any lockout tagout procedure. Main risk factors from contacting energy sources, and we've included 2 photos to try and illustrate what may happen if you touch or you're engaged in a piece of equipment without proper lockout tagout. Some people feel that you shouldn't include these kind of negative imagery. My experience, it's always a good best practice to illustrate to workers the consequences of not following proper procedures. So in dealing with electricity, of course, the major risk is electrocution, and if you're working, something as simple as 120 volts can cause some nasty accidents, especially if you're working off a ladder. But any of the other energy sources up from 120 up to the 575s that are used on a lot of our facilities, these are magnitudes that kill. The other risk in working with an electrician is the flash, and if anybody's ever seen an arc flash or had any experience with it, very, very serious. You can get some nasty burns from it. And once again, my recommendation is to use arc flash protection anytime you're working on those higher voltages. It's just a good safe precaution. Anyway, we'll have some further information. They can contact me about it. The next major risk is around entanglement, and you see this person here caught in a very serious accident and some conveying equipment. Most of our plants these days, certainly on new manufacturing, has all kinds of conveying, live roller conveyor, drive chain, and all of this equipment can cause very serious accidents if a part of your body happens to be engaged or caught in a bite, or working with any piece of operating equipment that's not properly locked out. And then the next is the injuries that would include crushing, amputations, possible death. So this is a good, at this point, at this juncture in the presentation, I usually ask people if they've ever been caught in similar situations, try and get a dialogue going as to, you know, what the potential risks are. My experience, this brings out lots of information on previous injuries at other plants where you can use them as good illustrations of what you should and shouldn't be doing in lockout tagout. So going over management responsibilities, certainly we talked about your responsibilities at the start of the presentation as defined by the local regulations, but a review of these regulations and your responsibilities are detailed on this slide. So as an employer, you are responsible for ensuring all equipment and machines in your area are on a master lockout list, and we'll talk about that in a minute, and that they're capable of locking out. So if the machine, if you have a stacker and it's 25 years old and it doesn't have a device that allows it to be locked out, and you don't have any procedures explaining how that stacker is to be locked out, then you're deficient in your responsibilities as an employer. And my advice to you would be to go back either to the original equipment manufacturer and ask for some advice on how to install lockout devices, or a more expensive method is to bring in a safety consultant who can work with an electrician or mechanic to install them. I've done that myself. I know some guys that know how to do it and do it well. But certainly your responsibility is to make sure that that master lockout list is comprehensive and that all your pieces of equipment inside the plant have the capability to be locked out. Your second responsibility is to detail who is authorized to perform lockout. So this is critical. You know, if you don't want anybody in your plant working on major electrical, major mechanical, major pneumatic, then inform them so and list the contractor that's allowed to do that work with his contact numbers. This is absolutely important because in my experience, this goes with, especially with those keen production types where they engage in line jam clearing or some peripheral lockout tagout programs in order to keep a piece of machinery running, not fully understanding what they should be doing and shouldn't be doing. And of course they get hurt. And when asked, why did you do this? They said, well, I wanted to keep the line running. The employer's responsibility is to explain to all workers who's allowed to do lockout tagout, who's not allowed to do it, and what the steps are if a piece of machinery is malfunctioning, who do you contact in order to shut it down, properly service, and properly return it to service. The third responsibility, ensure authorized employees have the locks, the tags, and the devices necessary to perform lockout. The fourth is to provide training to authorized personnel, and that's done in the form of a written procedure for each piece of equipment. So today we're going over a general procedure, but the rules and regulations would tell you that if you don't have training documentation demonstrating that your mechanic has been trained to properly lockout tagout an end-of-line stacker and he gets hurt on it, you're going to be charged with at least 3 failures to properly follow legislation. So I can't emphasize this any more than make sure you have workplace-specific procedures for each type of equipment that you're operating in the plant. That includes saws, stackers, conveyor lines, forklifts. And we'll certainly be able to help you if you need some additional effort on designing one of those procedures. But you see one in front of you. This is a similar type of procedure that I experienced in working with and developing in my previous employment. And these are good procedures, but they're done by somebody who knows what they're doing in identifying energy sources on a piece of equipment. Next responsibility is enforce lockout-tagout procedures. So, for example, I talked about earlier the need to dissipate or bleed off air before you engage lockout-tagout. It's the responsibility of the employer, and that may be a supervisor or a plant manager, to enforce that step in the procedures. It's the employer's responsibility to make sure that your procedures are being followed inside the workplace. Second last step is to annually review your lockout-tagout policy and procedures and update where necessary. The reason this is done is throughout the year, various pieces of equipment are worked on, and sometimes some changes have been done, okay? And you haven't, as an employer, picked up on what those changes have been. So a good best practice is once a year, go through your procedures on each piece of equipment with your health and safety committee and make sure that they're current and they accurately describe the lockout-tagout procedure. And the last one is to ensure that any new or modified equipment is capable of being locked out and added to the master list. So you decide that you want to add a waste conveyor line, you install it. You want to make sure that that new line has the proper devices and that you have written procedures for locking it out, and it's added to the master list. So as I mentioned, one of the challenges that I've had to deal with over my career is getting contractors who are coming on site to follow lockout-tagout procedures. Contractors, by definition, are not your employees. They're often quite independent, and they have their own way of doing things. What's important at this juncture to understand is you, as the employer, you're responsible for a contractor coming on site, and it's your responsibility to make sure that all contractors coming on site are informed about your policy and procedures, and secondly, that you make sure that they follow them. So typically this would involve sitting down with the contractor once a year and making him sign off on a policy, that he understands it and has read it. Provide him with copies and demonstrate proper lockout-tagout procedures on the equipment that he's going to be working on. When he comes on site, this might involve reviewing a lockout procedure, a written lockout procedure with him. It might involve job shadowing. These are all best practices to make sure that the contractor follows the proper procedure when he's working on the equipment. Can't emphasize any more than that this is a major area of risk in most facilities, and in my experience has been a reason for some very severe accidents in the workplace where the contractor failed to properly follow procedures, or local management failed to make sure that the contractor was following proper procedures, and you don't want to put your business at risk in doing so. What's a master lockout-tagout list? Well, this is a list that identifies, and a sample is written below. So this is, it identifies all the equipment requiring lockout-tagout inside your plant, the types of energy. So in this case, we're talking about stacker number 2, and you've highlighted the electrical, which is 575, the pneumatic at 120 psi. It talks about the procedures specified for shutting it down, where to find those ISO devices, who's authorized to do the work, and this master list is maintained and updated on a regular basis, reviewed annually. It's the employer's responsibility, and it's the tool that you use to train your authorized personnel. Once again, if anybody needs some help in trying to develop a master list or wants it reviewed, they can give me a call and do this offline. So, summary: how to prevent injuries and contacting energy sources. Management provides written lockout procedures in consultation with the safety committee. Why do you do it in consultation with the safety committee? typically these people understand how the machine really works, okay, and they give you direct visibility on areas where you may not fully be aware of how that machine operates in practice. So in my experience, anytime I do written procedures in the workplace, I engage the Health and Safety Committee. Procedures are posted at all machines, and that eliminates the excuse of, well, I didn't have time to go back and dig up the proper procedure, so I skipped a couple of steps and I forgot this. And you want to eliminate that excuse at all times. So best practice would be to post the procedures at all machines. All affected workers should have generic lockout-tagout training to make them aware of the risks. Ensure that they understand that only authorized workers, including supervisors, are allowed to do a workplace and machine lockout, a specific lockout-tagout. Ensure that contractors follow the company's lockout procedures and review your procedures on an annual basis. Now, I've included a short competency assessment. Once again, what's important about doing competency assessments is a written assessment done in the classroom just doesn't cut it. It can be a first stage, but really what you want to do is take, let's say you've hired a new mechanic, and you're training him on all of the equipment, and you want to take him out to stacker number 2 and say, okay, let's follow proper lockout procedures on this particular piece of equipment. Show me how it's done properly. And you document that in your training log. Once again, I have to emphasize that all regulatory authorities are looking for not just training in general, but they're looking to see if there's machine-specific training for your authorized personnel. So I would emphasize that you want to document that clearly, that the people who are authorized to do lockout, tagout have the training on each piece of equipment. And that is the lockout, tagout seminar on as part of our group safety group exercise. And I want to thank you for attending, and we expect to have one more around machine guarding within the next couple of weeks. Thank you very much. All the best.